Let's talk a little bit about trigonometric ratios. Well, they're called ratios because, well, they sort of look like fractions. It's not that, big a deal about it, but few things to note. First of all, it generally always surrounds a right angle triangle. And if you looked at my video on Pythagoras' theorem, then you're going to discover one thing you know about right angle triangles already is that this side, the longest side or the side opposite that right angle, is always called the hypotenuse. So I will label the sides for you. So the H represents the hypotenuse. There we have our hypotenuse. The O represents the opposite side, and the A represents the adjacent side. Now, looking at our right angle triangle here, a few things we should note straight away. First of all, always try to identify where your hypotenuse is, and it is opposite the right angle. The next thing to note about our right angle triangle is this. We have now got an angle in here. The angle could have been up there, but it's here at this time. And for that angle, the side that's directly opposite that angle is called, well, the aptly named opposite, the opposite side. And last of all, we have a side that is touching the angle, and this is our adjacent side right there. So three things you should find out. First of all, before you try solving anything, where is your hypotenuse? Always opposite the right angle. Your opposite side is always opposite the angle, and your adjacent side is usually touching that angle along with the hypotenuse. That's fine. So now we have our trig ratios. Our trig ratios state that for sine theta, some people call it sin, but it's sine, and theta is just an angle, okay? Just an angle. There's a representation for an angle in maths. So sine theta is the opposite side divided by the hypotenuse side. Cosine theta is the adjacent side divided by the hypotenuse side. And last of all, tan theta, or tangent, is equal to the opposite side divided by the adjacent side. Now, some people find that really difficult to remember, so they've come up with all sorts of ways to remember. Some people took like the first letter of all of the words that you are going to use and came up with this word, sohcahtoa, which basically means sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tan is opposite over adjacent, which is exactly what we've got here. If you can help it at all and you have a very good memory, just memorize these, okay? Now, let's just say you can't remember. I've got a nice little diagram here that I'll be using as well to help you with working out your different sides and angles. I will put it out there now. I don't really like using these triangles because they're not proper algebra, but I will show you both the algebra and the triangles. So if you're struggling with algebra, it means that you can still do this. Oh, here we are. We have our first problem. Before we get started, let's label the sides. Well, that is opposite the right angle, so that has to be my hypotenuse. This side is opposite my angle of 43 degrees, so this must be my opposite side. And this is touching the angle, so this has to be my adjacent side. Well, the first thing I'm going to do is look at what I've got and what I need to find. What I've got is an adjacent side. I've been given that. And they want me to find the opposite side. So what I need to do is go back and check to see which trig ratio deals with opposite and adjacent, and that is tan. It deals with opposite and adjacent. It is opposite over adjacent. Go back and look at my problem, and I know that I'm using tan theta being opposite over adjacent. Theta is the representation of my angle, so that's going to be my angle. So I'm going to now say tan of 43 is opposite, which is A, over my adjacent side, which is 11. So A over 11. Now I'm going to do a quick bit of algebra. I want A to be on its own, so I need to get rid of this 11. The 11 is dividing by A, so to get rid of it I need to multiply by 11. So I'm going to multiply by 11. And if I do that, I'm going to get 11 times tan 43 is equal to A. And now this is pretty easy to work out, because all I need to do is punch this into my calculator. Make sure your calculator is in degrees mode, otherwise you'll get the wrong answer. Punch this into my calculator, and that's going to give me the answer I'm looking for. Alright, so here we go. Right, quick bit of calculations there, and that gives me 10.3 to 1 decimal place is equal to A. Alright, now let's look at the triangles I've got up here. Now, because I knew I was using opposite over adjacent and I was using tan, I could look at this little triangle on the side here. Now, that is going to give me something like this. I was looking at tan 40, let me just write that in, tan 43, my adjacent side was 11, and my opposite side is A, which is what I was trying to find just now. So for the triangle it works like this. Because I'm trying to find my opposite side, which is A, what I'll do is I will sort of cover that, and I'm going to say, well, okay, I'm trying to find that, so I'll just cover it up. And what you have left is what you can see down here, which is tan 43 next to 11. Basically, what that means is tan 43 times 11, which is what we have done here. So that's how you use the triangle. Let's look at another problem. So here I have a situation where I need to find two missing sides. Well, before you start anything, like I always say, identify your sides. So here, opposite my right angle has to be, yes, you guessed it, it's my hypotenuse. And let's start with finding where the opposite is. That's going to be here. So this is my opposite side. And last of all, touching the angle has to be my adjacent side. Next time, if you want, you can pause the video and see if you can figure it out before I do. Anyway, let's find x first. Let's find x. I'll go in alphabetical order. It makes sense to find x first. So, to find x, I'm going to make use of my hypotenuse, and x is my adjacent. And you need to now remember which trig ratio to use. I will tell you that you should be using cos. So cos of the angle is adjacent over hypotenuse. The angle is 20 degrees, so I'm going to say cos of 20 degrees is adjacent, which is here, divided by hypotenuse. Adjacent is x, hypotenuse is 12, so x over 12. Again, x and 12 are dividing. I want x to be on its own. 12 needs to go. to get rid of 12. The inverse operation means I need to multiply by 12. So I will get 12 times cos 20 is equal to x on its own there. Now it's a simple job of punching that in my calculator, which now gives me 11.3 as x. So now I know that my x value is 11.3. Alright, that's fantastic. Now we need to go and find y. Well, there are loads of ways we can find, well, not loads, there are a couple of ways we can find y. We can either use a trig ratio, because y is the opposite side, so we can use opposite over hypotenuse if we want. We can use opposite over adjacent if we want. But I'm going to use Pythagoras because I want to remind you that Pythagoras is still lurking in the background and can still be used. So here we go. Remember, Pythagoras says we need to start with our hypotenuse first. So we're going to start with 12 square. That equals to 11.3 square plus y square. If you are completely lost at this point with Pythagoras, you need to go and watch that video. Because when you're doing this, you need to be versatile, being able to switch between trig ratios and Pythagoras. So anyway, I want to get y, so this 11.3 square will need to go. So I will end up with 12 square, take away 11.3 square is equal to 11.3 square is equal to y square. Quick bit of working out in my calculator is going to give me 16.31 is equal to y square. And remember, if I need to find what y is, I square root 16.31 to find y, and I'll just put the answer over here. And once I square root that answer, it's going to be 4.04, just the 2 decimal places. So y is equal to 4.04. All right, now for us to look at today, and then you're going to have a go at doing your own ones, is finding for us a missing angle. As you can see here, we have a missing angle there. Well, let's see what we've got first. Again, before you start, identify your sides. So this has to be my hypotenuse because it's opposite the right angle. This has to be my opposite side because it's opposite my main angle. And this is my adjacent side there. I don't really need to label it because I don't need it. Now, I have my opposite, I have my hypotenuse, and now I'm going to find the angle. Well, the trig ratio that deals with opposite and hypotenuse is sine. So sine of the angle is opposite over hypotenuse. The angle I don't know, sine of the angle, is equal to opposite. The opposite is 14, the hypotenuse is 20, so it has to be 14 divided by 20. All right, bit of a trick here now. Every time you're going to find the angle, you have to, well, let's call it separate sine from the angle. You have to divide by sine on its own. And that basically means taking the sine inverse. When you divide by sine, that's what you're going to end up doing. So theta on its own, or the angle, is equal to sine inverse of 14 over 20. Again, make sure your calculator is in degrees before doing this. And you'll need to press shift for this one. All right, so once you press shift and then sine, your calculator will show you sine inverse, and then you just put the fraction in, and that is going to give you an answer of 44.4 degrees. Yes, it's in degrees because it was an angle we were finding. We're finding that missing angle over there. All right, this one, you notice I haven't left any help for you. So pause the video, have a go at finding this missing angle here and see how you get on. I'm just going to write down the answer that you should get after you've done all your working out. All right, I reckon this is what you're going to get, 16.3. All right, I hope that's the answer that you got, and I hope you've learned something about finding missing sides and angles using trig ratios from this video. Have a go at doing some of your own problems and see how you get on.